Sagar Institute of Science and Technology, Gandhi Nagar, Bhopal. Dear all, in Ramcharitmanas, Goswami Tulsidas has written, Chitijal Pavak Gagan Samira, Panch Tattva Mil Adham Sarira. It means whole universe is made up of 5 elements and water is one of them. It is a nice opportunity for all of us to hear from our today's expert, Mr. Jaroslav Moško, whose broad area of research is water treatment. Before starting the event, let me introduce SISTec. Sagar Institute of Science and Technology is a part of Sagar Group and it came into existence in 1983 under the visionary leadership of Chairman Sri Sudhir Kumar Agrawal. Over the years, it has now transformed into one of the largest corporate houses and business conglomerates of Central India. In its journey of over 4 decades, the group has successfully ventured in the field of education, real estate, production, and manufacturing to employ 5,000 plus people and impact the lives of more than 1 lakh people every day. Sagar Group has also been felicitated with Performer 2021 by ARIIA Band, Industry Innovation Council IIC 3-star rating, Excellence in Promoting Industry Academic Interface Award by SHM India during 14th National Education Summit and Annual Excellence Award 2021. National Employability Award 2021 by Aspiring Minds for being among the top 10% engineering campuses in Madhya Pradesh and many more. Since its inception, year 2007, Department of Mechanical Engineering, SISTec Gandhi Nagar is constantly working towards enhancing the knowledge of faculties and students in diverse areas through faculty development programs, short-term training programs, workshops, expert lectures, etc. Now, I would like to invite Principal of SISTec, Dr. Kesavendra Chaudhary, to say a few words about this event.
Thank you, Dr. Sanjay Singh, sir. Today's speaker, researcher Mr. Jaroslav Moško, HOD Mechanical Engineering, Dr. Ravishankar Chaudhary. Today's program coordinator, Dr. Sanjay Singh, other faculty members, and all my dear students. Good afternoon, and I welcome you all in today's expert lecture on thermochemical treatment of sewage sludge, organized by Mechanical Engineering Department, SISTec, Gandhinagar. Thermochemical treatment of sewage sludge is very much important to optimize the heavy metals quantity available with it, as its availability in optimum level improves the plant's nutritional level and also several mechanisms essential for the normal growth and better yield of plants. The presence of heavy metals in excess becomes toxic for plants that switches the plant's ability to uptake and accumulate other non-essential elements, which results as the damage of cell structures. Thermochemical treatment of sewage sludge is also required to transfer phosphorus into mineral phases available for plant. Phosphorus is an essential element for all living organisms and cannot be replaced, and sewage sludge is perceived as a potential source for it. Now you are able to understand that why thermochemical treatment of sewage sludge is very much required. I hope all the participants will try to learn the most from this expert lecture, and if possible, also try to do some research in this area. Thank you, Dr. Jaroslav, for accepting our invitation to deliver such important and valuable talk with our students and faculty. Happy learning, and thank you, everyone.
Thank you, sir. Thank you for your valuable words. Now, before starting the expert lecture, let me introduce our today's speaker, Mr. Jaroslav Moško. The researcher Jaroslav Moško is affiliated with the Department of Environmental Engineering of the Institute of Chemical Process Fundamentals of Czech Academy of Sciences. He obtained his master's degree in environmental technology from the Faculty of Environmental Technology of the University of Chemistry and Technology, Prague, the Czech Republic. Following the master's degree study program, Jaroslav continued his research in double degree joint PhD study program at the Faculty of Environmental Technology of the University of Chemistry and Technology, Prague, the Czech Republic, and at the Faculty of Bioscience Engineering of the Ghent University, Belgium. The research topic of the PhD study was modern methods for material and energy recovery from sewage sludge. The current research topic, Jaroslav, focus primarily on treatment and utilization of sewage sludge. Besides the research related to sewage sludge, Jaroslav is further involved in the research projects focusing on biochar from waste biomass application to solve drought intensively farmed areas, alternative sources of nutrients for agriculture practices, organic pollution reduction in fresh water, etc. Now, I am inviting speaker Mr. Jaroslav Moško to start his lecture. Over to you, sir.
Thank you, Professor, for a kind introduction. Okay, I will start with sharing.
आ गया भैया याशिका आ गया फॉर्मर.
So I hope you all can see the shared screen.
Yes, sir.
Okay, perfect. So I welcome you everyone to today's presentation on thermochemical treatment of sewage sludge, which I decided to divide into, let's say, two main parts. The first one would be including a brief introduction into sewage sludge problematics and the current state of the art. I will be focusing mostly on the Europe, because that is where I'm basically seated and most of my knowledge comes from. And in the second part, I would like to share also a little bit of my experimental campaign and my own research, where I would like to present you some interesting or maybe unexpected results which I obtained during my studies so far. Briefly, what the sewage sludge is. Sewage sludge is basically the waste stream of the wastewater treatment. And on this basic scheme of the wastewater treatment plan, we can see that we differentiate several different types of sewage sludge. Those are primary sludge, which comes from the primary clarifier, secondary, or other words, activated sludge, which is biologically activated sludge. Bringing those two sludges in together, we name this raw sludge, who is further treated to stabilize it and to hygienize it. I will get to that a little bit later. And today's lecture will be mostly focusing on the stabilized sewage sludge disposal or use or treatment. Also, before we begin, I would like to show some properties of sewage sludge for consideration, because today's lecture will be mostly dealing with these properties. First of all, that would be a high water, respectively moisture content. The sewage sludge, as we saw, the stabilized one, after the anaerobic digester, usually contains around 95 to 97 weight percent of water, then it undergoes dewatering and still contains around 75 to 80% of water. The other why we are dealing with sewage sludge are the phosphorus, nitrogen, and organic matter content. These are especially important from the point of view of potential agricultural use or treatment of sewage sludge, especially because nowadays phosphorus is currently on the critical list of raw materials of European Union. That means we basically in Europe have no resources of phosphate rocks, and we are dependent on import of phosphorus for production of fertilizers. Sulfur content is also important, especially in the thermochemical treatment, because the gaseous pollutants of sulfur dioxide are of a big concern. Ash content. Ash content of sewage sludge is relatively high, that can be around 50% of the dry matter, in which most of the heavy metals, but also other usable metals like calcium, magnesium are concentrated, and together with that also phosphorus is mostly bound to the ash content of sewage sludge. As we already heard, heavy metals are of a big concern of sewage sludge, especially because they pose a risk to environment and plant, animal, and human health. Together with those, we must consider also the pathogens which are present in sewage sludge, and especially nowadays or recently, a high concern are organic micropollutants which are present in sewage sludge. Those would be industrially produced persistent organic pollutants or other pharmaceuticals and personal care products, hormonal compounds, and so on. And as well, today's concern is the content of microplastics, which are inevitably present in sewage sludge. Besides that, to dispose and to operate with sewage sludge further, we also need to hygienize the sludge. Hygienized sludge means it has been treated in a way that numbers of pathogenic microorganism indicators have been reduced to a required level. To do so, we have several ways how to proceed. We can use and combine the processes of pasteurization, hydrolysis, and anaerobic or aerobic stabilization. Or we can use lime addition for killing the pathogens, or ideally, and especially if speaking of thermochemical treatment, sewage sludge drying, which besides that it hygienizes the sludge, it is the first step before either incineration or other thermochemical processes which must be considered. Nevertheless, these technologies do not address the problems of increasing levels of organic micropollutants. To briefly show the situation on sewage sludge disposal in European Union, we may see that around 1/3 is used in agriculture on the soil as the fertilizer, around 1/3 is incinerated or co-incinerated, the rest is for composting, landfilling, or some other disposal ways. This data were obtained from Eurostat, and it's been a data which were a bit latest because the statistics are not complete up to date, but at least this picture can show us more or less the situation nowadays. If we see this picture, we can also see that the variability within the member states of Europe varies significantly. We can see that countries like Switzerland or Netherlands basically incinerate all of their sewage sludge. On the other hand, there are countries like Belgium, Czech Republic, let's say, France, or other which use sewage sludge in agriculture in a high loads. And unfortunately, I must say that there are still countries that use sludge or they dispose sludge on the landfills. So now let's speak about these three main ways of sewage sludge disposal. I will describe some advantages and disadvantages of these disposal routes. If I was saying of unfortunate landfill disposal, you may see that there are basically no advantages on this use. Probably the one I might mention would be that it is, among the others, it is probably the cheapest option nowadays, but within the frame of environmental protection, this is not an option anymore. As we may see, there are disadvantages like leaching of the pollutants at the deposit, smell, and finally also legislation restrictions in many countries. Basically, in many countries, especially the developed countries, landfill disposal of sewage sludge is not allowed anymore. Now, if we move to disposal on agricultural soil or composting, and we may assume that compost would be also used in agriculture, then this option seems very reasonable because sewage sludge contains relatively high amounts of organic matter and nutrients. Nevertheless, besides the nutrients and organic matter, sewage sludges also contain heavy metals which may pose a risk to the soil and so on, as I already mentioned. And basically on this, there has been legislatively restricted sludges with the limits of contents of heavy metals and pathogens about these limits. And finally, also in some European countries, already limits on organic micropollutants have been settled, but this also varies within the European Union countries. Nevertheless, we may see that it is reasonable to use the precautionary principle in case of the agricultural use of sewage sludge. And finally, then there is a thermal treatment of sludges. Speaking of thermal treatment of sludges, we are mostly speaking of incineration or co-incineration, respectively. What are the advantages? These lead to a significant reduction in volume and mass of the waste, together with the destruction of organic pollutants. The valuable elements like phosphorus, calcium, magnesium are retained in the solid residues, speaking of ashes or chars. There is a potential for gain of the energy for production of heat and electricity, and this treatment makes sure that the sludge will be stabilized and hygienized. Nevertheless, as I already mentioned, there is a need for drying of the sludge prior to the thermal treatment of it. These technologies, among the others, are the most expensive, especially also because additional technologies for treatment of processed gases are needed. Those are needed for the prevention from nitrous oxide, sulfuric oxides emissions. And also there is this issue of public awareness, because people are often not quite happy to live nearby any waste incinerators. So just to bring brief semi-conclusions, landfilling is no more option. Agricultural disposal is strongly challenged by strict limits on hygienic state and precaution regarding the organic pollutants. And the thermal treatment is or shall be favored due to possibility of energy recovery and production of air-rich products. Based on this, I might say the best way would be to combine the agricultural disposal and thermal treatment. At first stage, we would thermally treat the sludge, and afterwards it would be used for agricultural purposes. That is also already the way, for example, in Germany. With their new sewage sludge ordinance in force since 2017, they make it mandatory to recycle phosphorus from sewage sludge or sewage sludge ash, respectively. But this is also a challenging issue. I will get to that a little bit later. In the category incineration, we must also consider co-incineration. And the share, for example, in Germany would be, if I'm not mistaken, or if not much changed, would be around 50-50. Again, I will repeat this. Why shall we go this way? Because the organic pollutants are destroyed. Energy content in the sludge can be to a certain extent used for heat and electricity production. And also the smell problem is solved. These 3 points apply for both mono-incineration and co-incineration. Later then, speaking of mono-incineration, more than 90% of phosphorus is retained in the ashes. However, this all has high costs, and also the phosphorus recovery is questionable, especially because the plant availability of phosphorus from this kind of ashes is low. And speaking of co-incineration, especially it is logistically not as easy, and then we also lose the phosphorus in the co-incineration ashes and with its further disposal in landfills or somewhere else. So, speaking of the ash for production of phosphorus products, as I already mentioned, it shall be the ash from mono-incineration of sewage sludge. Nevertheless, it has a low phosphorus bioavailability. For that reason, we shall treat sludge ash as an intermediate product for further technologies which would treat the sludge ash. These technologies can be either used to separate phosphorus from the pollutants. Okay, I forgot to mention that as well. Besides the phosphorus, calcium, magnesium, and valuable substances, also the heavy metals are mostly retained in the sludge ashes. The other option is to transfer phosphorus into bioavailable form or product for phosphorus-based fertilizer production. I use this small picture just to briefly introduce that, technically speaking, of sludge ash and the technologies for its treatment, there are two ways. These are either wet chemical treatment processes, mostly based on leaching, or thermal treatment processes based on high temperatures. Both of these ways are technologically and economically demanding. As we may also see, not much of these technologies have been upscaled into commercial scale. Okay, this picture, I must say, is also a bit older, but it still reflects the nowadays current situation. For such a reason, we shall also think about the other treatment, thermal treatment processes for utilization of sewage sludge. And one of these would be pyrolysis. Pyrolysis is a thermal decomposition of organic material at elevated temperatures in oxygen-free environment. In other words, we may say this is a thermal transformation of feedstock into gaseous, liquid, and solid products. As you may see on the picture, and it is also logical that this process is endothermic. For that reason, we need to bring some energy in terms of heat or electricity, basically heat, and this heat can be provided, for example, by the combustion of gaseous and liquid products. And as the remaining solid residue, which I will be calling sludge-char, can be potentially used for soil amendment. Why to consider sludge-char for soil amendment? And I also want to mention that the difference between sludge-char and sludge ash would be that sludge ash shall be treated prior its application on soil, whereas sludge-char could be potentially used directly. That would be meaning some saving on economics for the further treatment. Sludge-char is a carbonaceous porous material which may provide several advantages if used on soil. Those would be preferably enhancing soil properties in terms of increasing water retention, prevention of leaching of nutrients, aerating the soil, and we may say also a bonus point would be sequestration of carbon dioxide into carbon form. Pyrolysis is a process which has several different parameters which influence it the most. Those will be temperature, rate of heating, and contact of primary products with high temperature. According to that, we may differentiate between low and high, or low, medium, and high temperature pyrolysis, slow pyrolysis or fast pyrolysis, and with short or long contact of primary products with high temperature. I will not go into much of the details, but usually fast rate of heating and short contact of primary products is in favor of production of liquid products. But if we are considering using sewage sludge and sewage sludge-char for the soil amendment, we shall go the way in the favor of agricultural soil amendment or soil amendment at all. For such a reason, those conditions I will be speaking in the next parts, and how we set up the experimental campaign would be on high temperature pyrolysis with a slow rate of heating and long contact of primary products with high temperature. Let me briefly move then to experimental campaign. The experiments were held in a quartz reactor which was put in the oven. This is a very simple experimental setup. We used helium as a carrier gas. Why using helium? I will get to that a little bit later. And we chose the temperatures in the range of 400 to 800 Celsius degrees. The 400 Celsius degrees would be used because that could be potentially called the first temperature or the lowest temperature for pyrolysis. And the 800 Celsius degrees would be with regards to practical and larger scale application of sewage sludge pyrolysis, mostly with regards to components and materials used. As we may see, this is a brief composition of the sewage sludge, and we can see that the content of nitrogen is relatively high. That's why we decided to use helium instead of nitrogen, which is often used in experiments for pyrolysis, because we had the preliminary experimental campaign where we used nitrogen itself, and in the end we found out that the mass balances were slightly affected by the high content of nitrogen, which may well, basically it makes it a bit more difficult in the end for the calculation of the gas composition. And we may also see the composition of the ash afterwards, and there, as I mentioned, we can see relatively high contents of phosphorus, calcium, or magnesium compounds. First of all, I would like to get to the material balance. As we may see, the increasing the pyrolysis temperature results in a decrease in sludge-char, and especially the highest declination, I might say, would be observed between increasing the temperature from 400 to 500 Celsius degrees. And that would be mostly because if we only pyrolyze sewage sludge at 400 degrees, a certain amount of organic matter which could be decomposed still remains fixed to sludge-char. As we may also see, the increasing the temperature resulted in the increase in the gas yield. And just remember that we would consider using the pyrolysis gas and also the liquid part for the combustion to provide the energy later then. this energy transformation, that basically means it is the distribution of the energy flows from the sludge into the pyrolysis products. We may see that the relatively highest contents of energy remain in the liquid, plus the sum with the gaseous product. I did not bring this to the presentation, but just to briefly explain, around the temperatures at higher than 500 Celsius degrees, around 50% of the energy contained in the sludge is transformed into liquid and gaseous products. Just on a brief energy balance, which I did a couple of days back for this presentation, I found out that theoretically this energy could provide around 80% of energy demand for drying and pyrolyzing the sludge itself. That basically means we can use all of this energy for the pyrolysis itself, and the remaining energy can be used for pre-drying the sewage sludge itself. For the gas composition, we may see that this is the composition of gas is strongly dependent on the temperature of pyrolysis. We may see that increasing the temperature strictly decreases the carbon dioxide content of the pyrolysis gas on the expense of the increase in hydrogen and carbon monoxide, which are the gaseous components which further provide the energy needed for pyrolysis after the combustion. These are combustible gases, and they provide the energy for pyrolysis itself. And as I mentioned, because of the sulfur content of sludge, there is a risk to emit sulfuric compounds into gaseous environment, and we would like to prevent that, apparently. This was one of the first interesting results which we obtained during the experimental campaign. Here we may see that increasing temperature decreases the content of sulfuric compounds in the gas itself. This is still reasonably due to the dilution of the sulfurous compounds in the increasing gas volume with increasing the pyrolysis temperature. Okay, I'm sorry, I did not mean to bring this one. And now let's go finally to Sludge-char properties itself. As we may see, the dilution was also caused because on the cost of retention of the sulfur in the Sludge-char itself. This came quite interesting from our point. That's why, as the researchers, you always try to find explanation for such cases. For that reason, we calculated the sulfur balance, and we found out that from the temperatures of 500 Celsius degrees and higher, the distribution of sulfur into pyrolysis products remained relatively constant. And for that reason, we tried to see what with the sulfur really happens. For that, we ran the X-ray photoelectron spectroscopy and also some traditional normative methods, standardized methods. As we may see in the picture or in the table on the bottom left, increasing the pyrolysis temperature basically resulted in the transformation of sulfurous speciation present in the sludge-char. That basically means that the sulfur contained in the sulfates or organic or pyritic forms transformed into sulfides. That also got confirmed by XPS analysis. And this may be interesting, and plus this also could be in the favor of the heavy metals retaining in the sludge-char and their immobilization, because those sulfide tend to bond or absorb the heavy metals present in the sewage sludge. Then I brought this parameter, HC molar ratio, hydrogen to carbon ratio. This is the parameter used to judge the quality of biochars or sludge-char being prepared. And also according to certifications and some legislation matters, biochars to be used on soil need to have this ratio less than 0.7. For that reason, we may see that in case of sewage sludge, at least the temperature of 500 Celsius degrees would be required. Another interesting point which we found was the heating value of sludge-char, because usually in the literature and also the logics would say the higher the temperature of pyrolysis, the lower the energy content of sludge-char. For such a reason, we again try to observe or try to find the solution for that. For such a reason, we were thinking that some other elements shall reduce themselves during the process of pyrolysis, and then they would be again releasing the energy in the calorimetric bomb during the analysis of the heating value. And one of such elements could be phosphorus, because the phosphorus reduced forms contain significant high amount of energy. Unfortunately, we did not make any approval on this, because we may observe that increasing the temperature of pyrolysis resulted in decrease of phosphorus in reduced form. Nevertheless, we may assume that there are other elements which might act as an oxygen carriers and might potentially reduce themselves during the process of pyrolysis, and one of such could be iron, which is also contained in relatively high amounts of in the sewage sludge. From this picture, we shall also see the amount of phosphate and pyrophosphate, which increased with increasing the temperature. Phosphorus compounds tend to easily bound to calcium or magnesium compounds, and usually such compounds are purely soluble. That means they would be acting they would not be acting as much of a fertilizers, because they would be highly stabilized in the sludge-char itself. This has the consequences a bit later then. I also mentioned that it has a porous structure, and we may see that increasing the pyrolysis temperature resulted in the increase of the parameters used for judging the porosity or the specific surface area. And some of you might ask, if we are considering sludge-char for soil amendment, why not to mention nitrogen? That is very correct. Nitrogen shall be also considered. Reasonably, the increasing the temperature of pyrolysis, the content of nitrogen in the sludge-char decreases. But not just that. If we may also see the speciation of nitrogen, depending on the temperature, or even not depending, we may see that only a small fraction of nitrogen is in the form of ammonium salt. That is basically the reason why to also speak about this is that the plants are only available to uptake the nitrogen in the nitrates and ammonium salts. That means in the inorganic form. But we may see that the situation in sludge-char is very opposite. I will also come to this later. And now I showed you some basic information or some basic characterization of sludge-chars. The other question would be how to use or sell such a product. In European Union, the new regulation was issued for laying down the rules on the making available on the market of EU fertilizing products. This, however, this regulation completely denies using sewage sludge for production of European fertilizing products. Nevertheless, then there is also a strubias. Strubias that comes from the shorts of struvites, biochars, and ashes. And this, let's call it initiation or a report. This report, however, tries to amend the regulation with new component materials, and those will be the struvites, biochars, and ashes. And unlike it considers using sewage sludge for struvites and ashes, it does not consider pyrolysis and gasification materials from sewage sludge to be used for production of European fertilizing materials. One of the reasons and one of the main reasons for that was the necessary science and impacts on human health and the environment is not in the place for organic contaminants. And these organic contaminants would be preferably the organic micropollutants, persistent organic pollutants, and pharmaceuticals and personal care products. We also ran an experiment on this issue. We decided to study polychlorinated biphenyls, and we may see that from the input of 280 nanograms per gram in the sludge, by the pyrolysis, we were able to remove them almost completely. Especially, let's speak of the temperatures of 600 degrees and higher. Other than that, we also considered the polyaromatic hydrocarbons because these polyaromatic hydrocarbons can be also produced during the process of pyrolysis, especially if the process is not run at controlled and well-established conditions. Again, we may observe that we were able to remove these polyaromatic hydrocarbons to a great extent. Here I will stay with the temperature of 400 Celsius degrees. Unfortunately, this temperature, the limit according to Strubias for pyrolysis and gasification materials on polyaromatic hydrocarbons content is 6 micrograms per kilo. However, the temperature of 400 Celsius degrees was not able to let us go below this limit. So again, we may conclude that temperature of 400 Celsius degrees for pyrolysis of sewage sludge is not enough. For that, I would also make a little bit of conclusions. As I already showed you, the pyrolysis can evolve interesting porous structure of sludge-char, and together with that, the pyrolysis also immobilizes heavy metals. I showed you that pyrolysis can effectively remove organic pollutants from sewage sludge, and for such a removal, we shall be speaking of temperatures, let's say, at least 600 Celsius degrees. Nevertheless, as I mentioned, the phosphorus and nitrogen obtained in sewage sludge char is in the forms that are not plant available, or other way speaking, their plant bioavailability is low. For such a reason, we shall rather not think of sewage sludge char as a fertilizer, but we shall rather consider it as the soil conditioner or improver because it can improve the soil physical properties. And because of the boast of still having the content of heavy metals, the application of sludge-char on non-agricultural soil shall be recommended. That means do not use it in agriculture, but rather use it on soils which are not heavily irrigated or not often irrigated and not often fertilized. Those could be, for example, golf carts or municipality parks and so on, or the soils in the skiing resorts. And I was speaking of the experimental campaign, but now I want to show you also the real technology. This is the pyrolyzer from the Prague company. This is a screw type pyrolyzer, and the sludge enters from left to right. From this, somebody might be asking, okay, but you don't use completely dry sludge, right? That is correct. So still a little bit of moisture would be remained in the sewage sludge prior to its pyrolysis. So what would happen? The sludge enters the pyrolyzer. First, the remaining moisture would be evaporated, and this water steam would be passing through the reactor. So by the time it would be reaching the end and outlet of the reactor, it would be also reacting in the gasification reactions with the solid particles of sludge-char. For such a reason, we decided to run some extra experiments. First, we tried to estimate what could be the potential content of steam in the pyrolysis gases. So for the estimation, we used the very principle logics. Let's say we said that, okay, at the beginning we have 10% moisture content of sludge, and for that we calculated that potentially in the pyrolysis gases the content of steam could be around 70% by volume. In such a case, we might be speaking of autothermal gasification. And what would be the effect of such process on the pyrolysis products? So mostly we can see it would strictly increase the hydrogen content of the pyrolysis gas. Such properties of gas are also needed in case to construct or to construct the pyrolysis gases burner in the right way. I did not bring this data for now, but we could also observe that it has a positive effect on the porosity of sludge-chars in terms that the content of steam increased the specific surface area and porosity of the sludge-char. And that would be the brief info into all of that. I would like to thank you for your kind attention, and you are welcome to bring your questions into discussion.
Okay. Any students, participants, faculty members, if you have any questions regarding this expert seminar, you please quote your question, raise your hands, and please ask to Jaroslav, Moško. Okay, let the students think about their questions. Sir, I have one question, a very basic question to ask in this. Sir, please let me know which is one of the best method for treating a sewage sludge treatment?
Oh, can you be more specific in this case?
I mean, in general, I'm asking, is there any treatment processes and methods are there, and which would be the most economical?
That is actually a tough and tricky question because, yeah, we have two ways how to look at this. Either but goes opposite. Either we want to go economic or we want to go environmentally friendly, right?
Certainly environment friendly, sir.
If we are speaking of environmentally friendly way, I'm definitely standing on the side of thermochemical treatment methods.
Okay.
And that would be also depending whether to decide for incineration or combustion or the pyrolysis. And there would be many factors would be implying into all of this. The quality of the sludge at the beginning, because for sludge-char production, probably it would be better to have sludges with low heavy metals content, because those get concentrated. So you want to have a low content of them in the resulting sludge-char.
Okay. Okay.
But also we shall consider other ways how to go with all this treatment, because for this you can also have, just now speaking of the incineration, what is more favorable? Is it better to have some centralized or decentralized incinerators, right? Because now we are speaking also of the phosphorus recovery technologies, and for those you definitely need certain amounts or big amounts of the ash itself.
Okay.
And for such reasons, for example, Switzerland decided to go the way that they basically shut down the decentralized incinerators, and on the other hand, they've built big incinerators so that they can collect the sludges itself. But that also comes on the expense of the transport, right? And transporting something from place A to place B also causes some emissions, because the ways of transport would be lorries or other means that would be using fossil fuels. If we want to have the whole global look over this.
Okay.
And then maybe we could be also thinking of the pyrolysis. If we want to go decentralized, probably it would be good to go with a smaller pyrolysis technologies.
Okay.
And for that also, the difference would be India is a big country very big country compared to Switzerland. Switzerland is a very small country. So here we can be thinking of the incineration rather than pyrolysis itself.
Okay.
Also, the difference in this case, if I can add one more thing, would be the fact that incineration or combustion is a well-established process, whereas the pyrolysis itself has many more other issues, especially on the stability of the process itself. You will always need to bring some energy into the system. Plus, you have various products from it other than just flue gases and ashes. So this all is way too complex.
Okay. Thank you, sir. Thank you. Any other questions, please? Yes, Sanjay sir, please go ahead.
No questions. Okay, sir. Now I would like to invite HOD of Mechanical Engineering Department, Dr. Ravisankar V. Chaudhary, to convey vote of thanks.
Okay. Thank you, thank you, Dr. Sanjay Kumar Singh. First of all, I would like to thank Mr. Jaroslav Moško for accepting our invitation and briefing a session on sewage sludge treatment in front of our students and faculty members. I would like to thank you for taking his time out to brief this session. And Apart from that, I would like to thank Mr. Vineet Singh Sikarwar, who was a bridge between us and Mr. Jaroslav Moško for to have this lead for lecture. I would like to thank the whole digital team of our SISTec, Mr. Gajendra Gaikwad, Ms. Madhu Kushwaha, and Mr. Pankaj Mangtani for all the efforts of making this session live through Facebook and YouTube, and all technical things which are hidden. They made us very comfortable to conduct this event. I would like to thank the faculty members of my department, Principal Sir, for allowing us to conduct this session. Before to end my talk, I would also request Jaroslav Moško, let us continue this kind of session, not only in the terms of expert lecture, but on the other hand for working along with you around on this also. Maybe it may be a research, maybe it may be a paper or else some projects, sir. We'll look forward for such kind of association with you in the days to come. Once again, I would like to thank all of the people who directly or indirectly connected to make this session a fruitful one. Thank you one and all, and special thanks to Jaroslav Moško, sir. Thank you. Have a good day.
Thank you. And